Okay, we've talked about indefinite integrals. Let's do a definite integral so you can see what that looks like. So x squared plus 4x minus 5 over x plus 2 and then dx. All right? So let's take a look here. Can I do a u sub? No, that's out. That's obvious. But is this really a trig pattern? Oh, it is not straight up like this. Remember how I said a lot of the things in 8.1 are things that we are going to be working on? This is completing the square. So when you have that quadratic, you can go back through here and do that complete the square. Complete the square. And when you complete the square, then you can see maybe I'll get a pattern out of that. Let's see. So I have x squared plus 4x minus 5. So x squared plus 4x plus x minus 5 minus x. And then I've got that x plus 2. When you square that, I've got a 4. So then we end here with x plus 2 squared minus 9. All right. Put it in there then. Oops. Under the radical is x plus 2 squared minus 9 over this x plus 2. Now you see the pattern, right? Okay, so with our pattern, I know that this x value here is going to be x plus 2, and my a is a 3. So x plus 2, and you can do an additional sub. We're not going to. You were just going to say x plus 2 is that x value, so it's on that side, of 3 secant theta, right? So then x is actually 3 secant theta minus 2. So the derivative of that would be 3 secant theta tangent theta d theta, because the derivative of the constant minus 2 is just a 0. And now you plug it all in. Wait. We have to change our bounds. It's a definite integral, right? So at x is equal to 4, theta that we're looking at here is equal to 4 plus 2 is equal to 3 secant theta. Okay, so 4 plus 2 is a 6, divided by 3 is 2 is equal to secant theta. So then theta, remember this is reciprocal of cosine, so I look and I say, where's cosine 1/2? That's up here at pi over 3. So then that's where I end up with theta is now equal to pi over 3. And at x is equal to 1, I've got 1 plus 2 is equal to 3 secant theta. Divide both sides by 3, and I've got 1 is equal to secant theta. Where is cosine 1? At 0, right? Okay, now let's do all the sub-ends. So I'm now going from 0 to pi over 3. And underneath the radical, because I replace x plus 2 with this 3 secant theta, so I have 3, I'm not going to write all that out. This is squared, so it would be 9 secant squared theta minus 9 over, again, I have an x plus 2, so this is 3 secant theta, and my dx is 3 secant theta tangent theta d theta. Really getting it smashed in there, aren't I? Those 3 secant thetas cancel out with those 3 secant thetas, right? Now I'm left with, scoot this up a little bit. I'm going to take out the square root of 9 in front, and I'm going to go still from 0 to pi over 3. And then I have the square root of secant squared theta minus 1 times that tangent of theta d theta. We know secant squared of theta is tangent squared, so the square root here of tangent squared theta times tangent theta, the square and the square root cancel out, and so I'm just left with 3 from 0 to pi over 3 of tangent squared theta d theta. Now I don't have some fancy little power reducing formula for tangent squared. However, we do have the Pythagorean identity. So this is the same thing as secant squared theta minus 1. And that is awesome because both of those have an antiderivative. Right? Heck yeah, they do. So 3 times tangent theta minus theta from 0. You guys are probably hollering at me. Great job. To pi over 3. Do I have to do a right triangle for this one? No. I'm not going back to be in terms of x. I have everything converted into theta when you have a definite integral. That's why you commit. You commit to the substitution. Because when you do a definite integral and you already have everything switched over to that variable, then just keep it as that variable. So I now have tangent of pi over 3 minus pi over 3 minus 3. Well, actually, I'm not going to put this 3 over here. We'll do like this. Oops. I hit the wrong thing. Minus the tangent of 0 minus 0. Which both of those are 0. But the tangent of pi over 3, let me squeeze this back in since I already did my unit circle up here. I barely did one. Let's bring it back down. Make it a little bit bigger. So at pi over 3, I know I have the coordinate point here of 1/2 square root of 3 over 2. So what's the tangent of that? Yeah, square root of 3. So 3 times the square root of 3 minus pi over 3, distribute that. And that's it. It's okay to leave that as your answer. And then you've got it. All right. For the definite integrals, just commit to that full theta. And then you just work it all the way out. You never have to go back to that right triangle. All right. Look for the pattern. What are the defining characteristics? Right? That is going to be our mantra for integration. Okay. Good job, guys. Now you've got all the patterns. Go rock the socks off of your homework. Go practice this stuff.